Déjeme ver. Equal canceling. Headset. Headset. Ah, bueno, felicidades. ¿Cuándo cae? ¿Cuándo cae? 15 de. Falta mucho. Bueno, cuando sea su cumpleaños, invite pastel. Sí. buenos días, mis estimados aprendices. ¿Cómo están? Espero que estén todo bien, todo azul. Vamos a, déjenme configurar lo que es la pantallita, speaker, es mi pin my video. Gracias, ay, mucho gusto, gracias a Dios. Estoy bien. Un poquito mal del estómago, pero no nada del otro mundo, ¿verdad? Nada que preocuparse a excepción de los que están enfrente mío, ¿verdad? Y los que están en casa no se preocupan. Por eso. ok. Bueno, permitamos a darle a admitir. Bueno, the last class, my dear student, we learned how to graph and analyze the quadratic equations. I mean, we learned how to calculate the vertex, symmetric axis, domain and range, and determine when the graph opens upward and when the graph opens downward, and also to scan the graph. All right, today we're going to learn how to solving quadratic inequalities. So if you remember, well, before to start to solving these problems, I'm going to give you a little review how to solving linear equations. Linear inequalities. In last year, in 7th grade, we learned how to solving linear inequalities by 3 ways. Interval notation, solution set, and obviously the number line. For example, just an extra example or a review, if we have 3x minus 6 greater than equal than 0, and if we solve for x, 3x greater than equal than 6, and x will be greater than equal than 2. This solution is represented by the interval notation. If you really want to know what will be the graph, remember this is -2, 0, +2, right? And because we are including the equal sign, we draw the circle, stain the circle, we draw the graph to the right side because to the right side, we will include the numbers who could be greater than equal than 2. That was the number line. And the solution set are the values greater than equal than 2. 2, comma, infinite positive. This is going to be the solution set. And in this way, we learn how to solving a linear inequalities. This is a simple inequality, compound inequality, absolute value inequality, etc., 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 etc. We learned all this stuff last year. Well, today, what are we going to do? We're going to have an extension of these inequalities, because today we're going to learn how to solving quadratic inequalities. In the quadratic inequalities, we're going to express the solution in 3 ways, just like the linear inequalities: interval notation, number line, and solution set. But we must follow a few steps to solving these quadratic inequalities. Okay, so let's going to try to solve the first example, because the instruction says solve the following quadratic inequalities. First the answer, interval notation, solution set, and number line. Okay, so let's going to deal with the first one: x squared plus x minus 12 greater than 12. To solving this quadratic inequality, we have to follow a few steps. Okay, for example, step number 1, transform the quadratic inequality into a quadratic equation and solve for the variable. This is going to be the step number one. Transform the quadratic inequality into quadratic equation and solve for the variable. It could be solve for x, y, z, depending what we're talking about. In the first one, we have x squared plus x minus 12 greater than 0. Well, instead to use greater than 0, I'm going to copy the equation just like x squared plus x minus 12, and this is going to be equal to 0. We're replacing the inequality symbol by the equal symbol. And remember, to solve this quadratic equation, we have three ways. Try and error technique, completing the square of quadratic formula. You can use whatever you want, all right? We're going to try to solve this equation by try and error technique, okay? Remember, we open a couple parentheses with the letter x, copy the first sign is positive. The second one will be the product between their signs, positive times negative will be negative. And we have to looking for a couple numbers. Their product gave us negative 12, and their subtraction gave us 1. And thus product will be x plus 4 and x minus 3. Because 4 times negative 3 is negative 12, and 4 minus 3 will be equal 1. So x plus 4 equals 0, x minus 3 equals 0. The nil factor theorem. And solving for x equals negative 4, and x equals 3. All right? This is going to be the step number one. Substitute, change transform the quadratic inequality into quadratic equation and solve for x. You can use the method as you wish. Try and error technique, or completing the square, or the quadratic formula. It's up to you. Step number 2. Step number 2, create a table of signs. Create a table of signs. How are we going to create this table of signs? All right, in this table of signs, we're going to assign a few columns. The first one, the name of this column will be the polynomial. Always, without exception. And below this polynomial, I'm going to write the first one. The first solution is plus 4. In the second row, x minus 3, I made the product between them, and downward, the product between x plus 4 and x minus 3. And you know that product will be given by x squared plus x minus 12. Always in the first column. Polynomial, the first term, the second term, and the last one, the product between them. You know, instead to write x plus 4 times x minus 3, you know, is the original problem. Now, in the second row, we're going to assign some kind of interval notations. What interval notation I'm talking about? I'm going to start from negative infinite, and finish with positive infinite. But I'm going to take or start from negative infinite, and I'm going to take the Jesus, Jesus Christ, Mary. A ver si no era COVID 2.0. All right. So I say it again. I'm going to start from negative infinite, and I'm going to take the smaller solution between them. And obviously, negative 4 is the smaller one, right? So it's going to begin. Parenthesis, negative infinite until negative 4. And if you see the quadratic inequality, at the beginning we have only greater than 0. I'm not using the equal sign. For that reason, because I'm not using the equal sign, I'm going to copy only the parentheses. All right? Always. If we have, for example, greater than equal than 0, instead parentheses, we'll be using brackets. The second one will be the solution between them. I mean, negative 4 and 3. I'm using parentheses because we are not including the equal sign. And finally, the opposite. I'm going to take the greater one. That will be 3 until infinite positive. All right. And we are creating the table of signs. Let me remarkable with the ruler. Mhm. Okay, we're creating the table of signs. Now, what will be the step number 3? The step number 3 is simple. Use a text point for every interval and evaluate each polynomial writing the positive or negative symbol. This is going to be the step number 3. How is that possible? It's simple. For example, in the first interval, we have intervals since negative infinite until negative 4. All right. You can choose a random number who's accomplish this interval since negative infinite until negative 4. Because this is a random number, I'm going to choose the negative 5, right? In this column. What I'm going to do, I'm going to evaluate the negative 5 in the first one, in the second one, and when I got the two signs, the product between them will be the answer over here. I mean, negative 5 plus 4, negative 1. I don't care the number 1, but I do care the sign because the sign is negative. All right, the answer will be negative. The second one, negative 5, negative 3 is negative 8. I don't care the number 8, but I do care the negative sign. So we got negative. And how about the answer? It's simple. The only thing that we have to
Mister,
do, uh-huh,
sorry, I got a little bit lost. Why do you put a -5?
because it's a random number. Choose a number between negative infinite and negative 4. You can choose negative 5, negative 6, negative 8, negative 10. It doesn't matter. That's why that was the step number 3. Use a test point. Test point means a random number. Understand?
So
Mhm.
is there like a certain number that you could recommend to use always? Like,
Yeah, this is the core depending the interval. If you have negative infinite and negative 4, choose one number between them. And that's it. It doesn't matter if you're using negative 5, you can use negative 10. For example, negative 10 plus 4 is negative 6. I don't care the number, I do care the sign, negative. Negative 10 minus 3, negative 13. I don't care the number 13, I care the sign. And because I have negative infinite and negative times negative, the answer will be positive. That's why the name of the table signs. That's it. For example, in the second column, we have the interval between negative 4 and 3. Choose one number, right? Choose one number between negative 4 until 3. Mhm.
two.
Okay, number 2, right? Now, this number 2 want to evaluate these two polynomials. 2 plus 4 is 6. Positive 6. I don't care the number, but I do care the sign. That was positive. Again, 2 minus 3 is negative 1. I don't care the number 1, but I care the negative sign. So that will be negative. And below will be the product between their signs. Negative times positive, positive times negative will be negative. We have the second answer, the table sign. And the last one,
Mister,
uh-huh,
is that I noticed something.
mm-hmm,
For example, in the one that was negative infinite and -4,
mm-hmm,
both of them were negative. So at the end, for the result, the answer was positive, and then on -4 and to -3, one was negative and the other was positive. So instead
yeah,
of doing all that, we just put the answer of multiplying the signs of the numbers that are in the
yeah, of
parentheses.
course, this is the main idea of this one, but we have to create the table signs always because the table sign can be varied depending the intervals, right? Depending the intervals, but you're right. Sometimes not necessary because we have negative, negative, the answer will be positive. It's depending what numbers do we have in the interval. That's why we really need to create the interval in the order. Negative infinite, taking the smaller one. In the second column, the smaller one with the bigger one, and the last one, the bigger one with positive infinite in that order. So in the last part, choose a number between 3 until infinite positive. Choose one number. Since 3,
6.
well, 6, 6, 5. 4, 7, it doesn't matter. 6. 6 plus 4, 10. I don't care 10. I care the sign. What's positive? 6 minus 3, positive 3. Okay, positive. And positive times positive will be negative. Okay, we are creating the table signs. Now, that's step number 4.
Mister, wait.
Uh-huh.
I didn't get the table thing.
In which part you didn't get it?
I
Why
don't get
is
Again.
it.
hmm
The
why is
part.
positive plus positive negative?
Again, choose a random number. And with this random number, evaluate the first polynomial. And the second one, 6 plus 4 is positive 10. I don't care the number. I do care the sign. Positive. See over here.
So basically, depending on the thing that we had on the side, the
hmm
parentheses,
hmm
we're gonna choose a number, could be
Of course.
anyone, and we will change it to x
Chocolate.
with the x, and we're gonna do the okay, got it. And in the back thing, in the down thing, that is like x, no, x plus
Mm-hmm.
x minus 12. We're gonna do the same, right?
Well, and actually, in this one, you don't need to do that. The only thing that you have to do when you have these two answers, multiply their signs, and that's it.
Oh,
Negative times negative, positive. That's why I'm changing the color. If you see, the black one will be the answer for the multiplying their signs. But
uh,
if you wish, you can evaluate by negative 5. Negative 5, second power, 25. Minus 5 is 20. 20 minus 12 is positive 8. Ah, positive. You can choose that one
me turn
if you
also.
wish.
Nancy was asking why positive times positive was negative. I didn't got
Over
it
there.
too.
Oh, no, because I'm not finished yet. I'm only
Ah,
write the negative, and when you ask me the question, but I'm not finished yet. This is going to be positive. Remember, at the moment when I write the line, you give me the question, and I'm stopped.
no, is that you did said
You
positive times
say
positive is
I
negative.
positive
said,
plus positive
Yeah,
is
you did say.
negative.
okay, sorry. I don't know what was I thinking. Sorry. Okay, so did you understand how to create the table sign right now?
Yay. Yes.
Okay, now in the final step, step number 4, solve the inequality. How we can solve the inequality? Simple. Interval solution, notation, solution set, and number line. The first thing that we have to do is solve by the number line. And it's simple. It's simple. If you see, the original quadratic equation says x squared plus x minus 12 greater than 0, right? Focus over here. Greater than 0. Would you like to tell me what numbers are greater than 0? What numbers are greater than 0? ¿Cuáles son los números más grandes que
One,
0?
two,
1, 2,
three,
3,
four,
4, and so on.
5,
That
6.
means, in simple merely words, all positive numbers, right? Well, what are you going to do? Simple. In the middle column, always, over here, we're going to draw a couple circles. I'm not going to stain the circles because I'm not including the equal sign, okay? Because I not include the equal sign, only draw the circles. And I'm going to draw the couple arrows in the lines who's matching the positive sign. For that reason, the first one will be located over here, and the second one will be located over here. All right? And this is how we can graph the number line. Number line. Because greater than 0, that means the positive signs. That's why I draw the arrow in the positive answers. Now, the interval notation. Sorry, the solution set. Remarkable, like a negative infinite, comma, -4, union, 3 until infinite positive. This is going to happen about the solution set. All right. And finally, the interval notation. Remember, every time that we have two separate lines, remember what the problem says. That means the values we're supposed to have over here will be given by x greater than 4, right? And, or, sorry, or x, well, no, greater than 4, -4, and x greater than 3. This is going to be the solution set between them. The value is greater than -4, positive. Values greater than the 3 will be positive. And we got the inequality. And that's it. That's all that we have to do. Questions? ¿Preguntas? Bueno, quisiera decirle que lo estoy viendo, pero no lo miro desde esta distancia. ¿Preguntas?
Mr. How
Ajá.
I didn't get also the line thing, the
The number
number
line. Well, the
Yeah,
number one,
like which numbers should we put in the number
you don't
line?
need to you don't need to put numbers. Only drop the arrows where the this matching the positive sign. The
Okay.
positive sign because the numbers greater than 0 obviously will be the positive. That's why.
Okay.
And the solution set will be the columns. Negative infinite, -4, because it's matching with the positive sign. And another one will be 3 and positive infinite. Understood?
Yes.
All right. Let's go to solve the second example. Let me copy the example in the right side to the whiteboard. The second one, we have 2x squared minus 9x minus 5 less than equal than 0. Okay, I'm going to move the camera a little bit to the right side. Okay, just a little bit to the right side. And let's going to perform the same steps. Remember, step number 1, we must transform that inequality into equation and solve for x. In this case, I mean, we got 2x squared minus 9x and minus 5 equals 0. Okay, a couple numbers that the product gave us 2, you know, that will be 2x and x. Copy the first sign is negative. The second one is the product between them. Negative times negative will be positive. So give me a couple numbers that the product gave us 5 will be 1 and 5. And let's check the answer. 2 times 5, 10x. Negative 1 times x is negative x. The answer gave us positive 9x. And that's supposed to be negative. All right, for that reason, I'm going to change the position of their signs and they'll fix it. Negative 10x plus 1x will be negative 9x. We are factorizing already. Now, let's going to solve this equation. I mean, 2x plus 1 equals 0 and x minus 5 equals 0. Solving for x, in the first one, x will be equal negative 1/2. In the second one, x will be equal 5. That was the step number 1. Remember, step number 2, create the table signs. Remember, the first column will be given by the polynomial. The second one, we're going to start for the smaller one, a negative 1/2. So negative infinite, comma, negative 1/2. But this time, because the inequality includes the equal sign, this time this number, instead to write the parentheses, I'm going to use the brackets because negative 1/2 is the smaller one between negative 1/2 and 5. The second column obviously will be these two solution set, negative 1/2 and 5. Again, I'm using brackets because I'm including the equal sign. And finally, will be the bigger one until infinite positive. All right, we have the 3 columns. In the polynomial, we're going to copy the first one, 2x plus 1. The second one will be x minus 5. And the last one will be the product between them. That will be 2x squared minus 9x minus 5. Okay. Now, because we are creating the table of signs, we must to assign one random number between them. For example, in the first column, negative infinite until negative 1/2. Choose a number, no, a random number who's accomplished this requirement. A random number, whatever you want. Mhm. All right, so he said 3, but 3 that's not possible because that's supposed to be between negative infinite until negative 1/2, and positive 3 is out of range. All right, choose one number. Negative
Negative
3,
5.
negative 3 or negative 5 could be. Yeah, perfect. Negative 3 or negative 5, it doesn't matter. Negative 3 times 2 is negative 6. Plus 1 gave us negative 5. I don't care the number 5, but I care the sign. And because the sign was negative, okay, that will be negative. Same happened with negative 3. Negative 3. Negative 5 will be negative 8. Okay. The answer will be negative. And because negative times negative is positive. All right. Another one. Choose a number, random number between negative 1/2 and 5. Choose a, excuse me, 4. Yeah, it could be 4. Yeah, it could be 4. 4 times 2, 8. 8 plus 1, 9. Positive. Another one. 4 minus 5 will be negative 1. Okay, negative. And negative times positive will be negative. And the last one, choose a random number between 5 until infinite positive. Will be 6, will be 7, will be 8, will be 9, will be 10. It doesn't matter. All right, number. 2 times 1 is 20 plus 1, 21. It's positive. 10 minus 5 is positive 5. And you know, positive times positive will be positive. Oh, we are finally create the table sign. We're complete the table sign. I'll do it a little bit quickly because we are almost out of time. All right, better. Now, how are we going to graph the solution? If you see the inequality says less and equal than 0. Would you like to tell me what numbers are less and equal than 0?
0.
Uh-huh. What else? Less and equal than 0.
Ah, negative
Negative.
1.
The negative numbers, the 0 and negative numbers. For that reason, this time I'm going to draw the couple circles. And because this time I'm including this equal sign, I'm going to paint the circles and the graph will be located in the negative sign because the problem says less and equal than 0. Over here. Oh, and this is going to be the number line, right? The solution set. Where's going to be located the solution set? Okay, the solution set will be located this bracket, negative 1/2 with 5. And the interval notation will be given by these two values. I mean, between negative 1/2 less than equal than x less than equal than 5. And that's it. That's all that we have to do in this purpose. Understood? ¿Entendieron? Perfecto. No se preocupen, copiamos 6 ejercicios. El día de mañana, si Dios lo permite, vamos a continuar resolviendo el resto de
Mister,
los
can I ask
problemas.
you a question?
Yeah, go right ahead.
What is the difference between using a bracket and a parenthesis? I always had that
Oh,
thought in.
simple. Parenthesis means you won't include the number. In the bracket, you will include the number. For example, if I said count the number since number 1 until 5, I mean, if I give you this command, count the numbers between 1 until 5. If I said that one, that means you're going to count the numbers since 1, 2, 3, and 4. And that's it. You're not including the number 5. But if I said count the numbers 1 until 5, that means you're going to start from 2, 3, 4, and 5. And if I said count the numbers between 1 and 5, and both have parentheses, brackets, sorry, 1, 2, 3, 4, and 5. Can you see the difference between them? Right now, what does that
Yes.
mean? Well, simple. And the reason why the negative infinite and positive infinite always have parentheses, because negative infinite, positive infinite never ends. That's why we are using parentheses. Understood?
Yes.
Okay, if I said double parentheses, I mean 1 until 5. Double parentheses, that means you're going to count 2, 3, 4, excluding 1 and excluding 5. Got it?
Yes.
Okie dokie. Another question? No questions? All right. Thank you so much, guys, for the attendance. Thank you so much, Abby. You too, miss. Have a great, wonderful day. Take care of yourself. Bye-bye.
Bye.
Bye-bye. So long. Take care of yourself.